In this video, we will be factoring differences of squares. Factoring differences of squares, we will be given something in this form, a squared minus b squared. We call this a difference of squares, a difference because we are subtracting. When we factor something in this form, we get the quantity a plus b times the quantity a minus b. It doesn't matter the order for which you put these two factors. You could have the quantity a minus b times the quantity a plus b. Either of these two are correct. Please note that a squared plus b squared, which is a sum of two squares, cannot be factored. This is a prime polynomial. Notice in the last chapter, we were given problems such as the quantity x plus 3 times the quantity x minus 3, and we needed to multiply that out. The intermediate step, we would FOIL, doing our first terms x times x, our inner terms 3 times x, our outer terms x times negative 3, and our last terms 3 times negative 3, and we would get these four terms. Then if there were any terms to combine, we would combine them. Notice the two terms in the middle, 3x and negative 3x, are like terms, and when you combine them you get 0. So we're left with x squared minus 9. Notice this is a difference, subtraction, of two squares, x squared and 9, which is 3 squared. Let's try some examples. In our first problem, we have x squared minus 16. 16 is a perfect square. 16 is equal to 4 squared. So remember our formula. I'll write it at the top. A squared minus b squared is equal to the quantity a plus b times the quantity a minus b. So in our example 1, a is equal to x, and b is equal to 4. So we can rewrite this polynomial in factored form by using our formula a plus b times a minus b. So we get x plus 4 times x minus 4. And that is the factored form. In our next example, we can rewrite this as x squared plus 49, which is 7 squared. Notice this is a sum of two squares, not a difference of two squares, and we cannot factor this. So this polynomial is prime. In our next example, we have 9x squared minus 1. 9x squared can be written as 3x in parentheses all squared. And we can rewrite 1 as 1 squared. So I want you to see that our a for our formula for a difference of squares is 3x, and b from our formula for difference of squares is 1. So we can follow our formula and add a and b, 3x plus 1, and subtract a and b, 3x minus 1. This is the factored form of 9x squared minus 1. Our next example, we can rewrite it as a difference of squares by asking ourselves, what squared is 4x squared? Well, 4 is equal to 2 squared, and x squared is equal to x squared. So we can rewrite 4x squared as 2x all squared. 25 is equal to 5 squared. So for our difference of squares formula, our a in this example is equal to 2x, and our b is equal to 5. So we can rewrite this in factored form as 2x plus 5 times the quantity 2x minus 5. In our last example, we have x squared minus 100y squared. Let's rewrite these to show that they are a difference of two squares. So let's rewrite this as x squared minus something squared. So we have to ask ourselves, what squared is 100? Well, 10 squared is 100, and y squared is y squared. If we square the product 10y, we get 100y squared. So for our formula for difference of squares, our a is going to be x, and our b is going to be 10y. And recall, if we are factoring a difference of squares, we use this formula, a plus b, quantity, times the quantity a minus b. So we can factor x squared minus the product 10y squared as x plus 10y times x minus 10y. So that is our factored form for example 5.